Today, we are going to teach you how to use the LTX 2.3 model to perfectly achieve local repainting, which is what we usually call Inpaint technology. It is a crucial technique when we want to make local modifications to videos or images. However, if you want to use this technology perfectly in LTX 2.3, there are still many issues you need to pay attention to. For example, if you want to change the beauty in the video into a female agent wearing a tight red leather suit, you might accidentally end up with a rather seductive and overly full-figured agent. So, how can we avoid this situation and achieve a perfect character replacement? Later on, we will summarize the key points for you. Of course, this kind of local repainting is generally random. For instance, here is a vertical video of a beauty dancing. We can change the image of this beauty into a female agent. But normally, the appearance of this agent is random, and we have no way to control it. But today, we will teach you a method to use a reference image to control the character you are rendering. At the same time, we will also cover a very important application of Inpaint technology, which is facial restoration. We have introduced many techniques for facial restoration in videos before, but more or less, they all had some issues. Can LTX 2.3's local repainting technology repair human faces really well? In this video, we will give you a definitive answer. To achieve local repainting using the LTX 2.3 model, we will use a LoRA. What you are looking at right now is the Hugging Face page for this LoRA. On this page, you can also see another very familiar LoRA called Edit. Anything, we have actually done a very detailed tutorial on that LoRA before. Some of you might have noticed that in this LoRA list, we can see two Inpaint models. One is trained for 2,500 steps, and the other for 10,000 steps. So which one should we choose? We are going to go with the 2,500 steps one. Besides downloading this model, you can also find the corresponding sample workflows in its workflow folder. Inside this workflow folder, we can see there are two workflows. One is the traditional local repainting workflow, and the second is a local repainting workflow with a reference feature. To achieve this feature, we need to use another LoRA. This LoRA is an R2V LoRA, but in this video, we will not use this model because I think it is too complicated. Instead, I will show you a trick to achieve the reference repainting function. To make the demonstration easier, I have also built the workflow on Running Hub. In the ComfyUI space, Running Hub is a fantastic online platform because whenever new models and extensions drop, they always follow up immediately. Additionally, Running Hub provides an online community platform for ComfyUI creators where you can find a ton of creative inspiration and sample workflows. Just like traditional Inpaint technology to achieve local repainting. Besides the LoRA we just mentioned, the most important thing is that we need to provide a mask. This mask is exactly the area we want to repaint. In our entire workflow, we will use the SAM 3.1 model to capture and locate the mask for the repainting area. Regarding the application of the SAM 3.1 model, we have already provided a very detailed explanation in a previous video. Also, please note that the LoRA used for Inpaint is not an IC LoRA. It is just a standard LoRA. Similarly, this is a two-stage sampling workflow. Next, let's take a look at the basic structure of the workflow. First is loading the main model. The main models used here are all provided by Kijai. The only thing you need to pay attention to is that all of Kijai's models are constantly being updated. So try your best to use the latest version. After loading the main model, you can chain this Inpaint LoRA. Notice that the version I am selecting right now is rank 128, and the training steps are 2,500. Next, let's look at this crucial step, which is using the SAM 3.1 model to get the mask. Pay attention. The video I just uploaded shows a fashionable beauty dancing in a dilapidated warehouse. The overall quality of the video is actually quite high. Now, I want to change this beauty into a female agent wearing a tight red leather suit. So we need to extract the mask of this character. As we mentioned when explaining the SAM 3.1 model, to get a mask from a video, we basically need to go through two steps. First, we grab the first frame of the video. In the prompt, I wrote female, referring to the female character. Then, we can use the SAM3 detect node to isolate and confirm this character in the first frame. After that, we use the SAM3 video track to search the entire video. Pay attention, guys. I have now designated this character as object 0. Therefore, when I use the SAM3 track to mask node, I can input the ID of this object. so I will enter 0 here as well. This way, we can guarantee that the object is 100% selected. But after extracting this mask, we need to apply some post-processing methods. If you look closely at this Inpaint LoRA, the mask color it accepts is white. Therefore, we must draw this mask area in white onto the image so that the LoRA can recognize it. Besides that, we have some other processing techniques. For instance, we will expand this mask a bit, and we will also pixelate or blockify it. Please note, there's a very important principle here. We do not want the model to be able to guess what is underneath this mask area. It is precisely for this reason that we apply the series of processing steps mentioned above, including mask expansion and blockification. All of this is to ensure the overall shape is more random, making it easier to control during rendering. Ultimately, we will name this control video. Next, let's take a look at writing the prompt. Here I need to remind you guys, this prompt should try to describe the entire video, portraying the overall scene, rather than just describing the area you want to modify. So here I will clearly write that I want a female agent wearing a tight red leather suit dancing in an old warehouse. Now, let's look at the most critical part of the entire workflow. How does our control video influence the sampling? Here, we will use a node called LTX add guide multi. The function of this node is to add some reference conditions for the LTX video generation. At its input end, it requires us to connect the positive and negative conditions obtained after encoding the prompt. And we also need to connect our VAE at the same time. We need to input an original latent. For this latent, you actually have various choices. You can pass in an empty latent, or you can take our reference video, run it through a VAE encode, and pass that into this latent. This doesn't really affect the final result. As for our control video, you can directly connect it to image 1. Since this isn't a single image but multiple frames, this node will automatically process it as a batch. Let's talk about this node in more detail. This node actually comes from Kijai's KJ nodes. This ComfyUI extension updates quite frequently, so the appearance of the node you see might look a bit different depending on the version. What you are seeing right now is a relatively older version, but regardless of what it looks like, its basic function remains the same. So after processing through this node, I will get a new positive condition, negative condition, and latent. The entire workflow remains a two-stage sampling workflow consisting of the base video generation stage and the upscaling stage. The basic settings in these two stages are no different from the workflows we've taught you before, so I won't repeat them here. Let's take a look at the final generated result. It is absolutely fantastic. Of course, when the beauty turns around, there are still some slight issues. This is an inherent flaw in video generation models and doesn't have much to do with our local repainting. Next, let me emphasize something for you. In the entire workflow, you must remember the principle for processing this area. Do not let the model guess what it is. Otherwise, this will cause massive trouble for your local repainting. To illustrate this point, let's look at this workflow. In this workflow, we use SAM 3.1 to extract the character's mask. Then I expanded it by 20 pixels and applied blockification, setting the block size to 8. The final result after the entire mask processing looks like what you are seeing right now. Looking at this, we can very clearly tell that this is a person. Naturally, the model can probably guess it too. Therefore, at this point, no matter how I describe in the prompt that this person is beautiful and has a very slim body, the result we ultimately get is this effect, an unusually full-figured agent. Now, keeping the same workflow, let's see what happens if we process the mask differently. The result will be completely different. Here, after extracting the mask, we first expand it by 20 pixels. Then, during the blockification process, I set the size to 32. This value is quite large. Notice how, after processing, the basic shape of the mask is fundamentally altered. Looking at this shape, we can hardly guess what it is. Similarly, the model will likely find it hard to guess as well. Let's keep the other content and parameter settings of the workflow unchanged and check out the final generated result. Take a look. This generated effect is fantastic. The character's overall figure is quite slim, and there are no issues with her posture or movements. Strictly speaking, this is a characteristic, but not a flaw. If you use it well, its advantages are very obvious. The reference video in the next workflow is a dancing beauty. The background is extremely simple. Just a white wall, Suppose my repainting intention is still to change this beauty into a female agent, wearing a tight red leather suit. Now, I do not mind if the final appearance of this beauty closely resembles the character in our original video. In this case, we can be much more casual with our mask processing. For example, when expanding, I only expanded it by 5 pixels, and for blockification, I set it to 8. You will notice that the overall shape of the beauty in this mask is very prominent. Let's take a look at the final in-paint result. This is also excellent. One glaring issue is that I explicitly wrote in the prompt that she is a long-haired beauty. However, because of the mask's shape, we can clearly tell it belongs to someone with short hair. Consequently, the final result is also a short-haired beauty. Next, let's talk about reference generation. When we introduce this Inpaint LoRA, we notice that within its local Repainting LoRA folder, it includes a LoRA model for reference generation, which is an R to V model. But as I mentioned, I won't use that LoRA. Instead, I will teach you a trick. Using this trick will still guarantee the successful implementation of reference generation. At this point, we need to make a modification to the workflow. The workflow I am using is still the dancing beauty workflow we just saw. Now, suppose I am not entirely satisfied with the generated beauty, or I want to predefine this beauty's appearance so that we can maintain character consistency as much as possible during generation. You will notice that we simply added a new image to this workflow. You can generate this image with any model. I used Nano Banana here. In this workflow, we connected the control video we used previously to image 2. In the previous workflow, we connected it to image 1. But now we are connecting this reference image to image 1. The rest of the workflow remains unchanged. Next, let's check out the final generated result. This dancing beauty video is truly magnificent. The agent's overall appearance basically perfectly matches our reference image. Let's analyze why this approach works. Notice that the core of this workflow is the reference generation node. References can be a single image, and of course, they can also be multiple images. So we can connect this character image to image 1 as a character reference, and connect the control video to image 2 as the area reference for local repainting. That is why we ultimately get this result. Finally, let's talk about facial restoration. Among all video generation models, facial restoration is a major headache for everyone. I feel that LTX 2.3's Inpaint technology is actually quite excellent for facial restoration. The overall effect is pretty good. For example, in this workflow, we simply need to change the prompt in SAM 3.1 to face. This allows us to extract a face, and then we just perform local repainting and restoration on it. The only thing you need to pay attention to here is that the mask area you extract should be as large as possible. Moreover, you need to break the shape of the face. If you retain the exact shape of a face, it is highly likely that the video you generate will look like someone wearing a sheet mask. Overall, the result looks great. But I must remind you, if the character's movements in the video are too fast, the in-paint effect might become unstable. The LTX 2.3 model itself has this inherent flaw. When a character moves too quickly, it becomes unstable. In this video, we walked you through the local repainting technology of LTX 2.3, because local repainting is an indispensable technique in video editing. Of course, we utilize the latest segmentation model here, which is SAM 3.1, and also emphasize the importance of the mask's shape. At the same time, we demonstrated how to adjust the shape of this area to achieve the best editing results. We also introduced a reference generation method. Using this method, we can provide a reference in advance for the character or subject being locally repainted, making the generation process much more stable. Finally, we covered facial restoration techniques and things to watch out for. Personally, I find the Inpaint technology incredibly practical. Alright, that is all for today. What are you waiting for? Go ahead and try it out yourself. Follow me to become someone who truly understands AI.